So basically this plane, this 2D body, it is rotating about an axis which is passing through O, and that axis is perpendicular to this plane, right? So omega is in that direction. So these quantities are expressed alternatively using cross product relationship of vector notation, right? Now the angular velocity of the rotating body, it may be expressed by vector omega normal to plane of rotation. Here we have represented omega normal to plane of rotation, and it has a sense governed by right hand rule. So this is R, along this direction you have V, okay, and from the right hand rule we get omega is in this direction. Now V can be, the velocity can be described as R dot, okay, which is nothing but omega cross R, okay, omega cross R. Okay, here just mathematically we have seen that V is equal to R omega. So if omega is perpendicular to both these planes, so omega cross R will give you the omega cross R will give you the exact direction of velocity V. Okay.
Yes, sir.
Right. So V is equal to R dot equal to omega cross R. Now R cross omega, that will give you minus V. So V will be in that case in this direction. Okay. So it will give you minus V. Now, how can you obtain acceleration of point A? By differentiating cross product of this expression with respect to time. Okay. Omega cross R, you have to differentiate that with respect to time. So in that case, what will you get? Omega cross R dot plus R cross, see here, omega cross R. Okay. So omega cross R dot and omega dot cross R, right? So this R dot is omega cross R. So this here you have omega cross R, and this you have omega dot cross R, right? Omega cross R again is what? The velocity. So omega cross V plus this omega dot is your alpha, or your angular acceleration. So this is how you can get the acceleration. Okay.
Yes, sir.
Right. Now, in case of particle motion, right? Say x and y are your coordinate, and you have translating coordinates, which is your small x and small y. Right? Say you have a particle B in space and you have a particle A in space. Right? We are only talking about translating axis. Okay, only there is translation. So in that case, with reference to this axis xy, what is the relative position of B from O? It is shown by position vector RB. Okay, and the position of A with respect to this O, it is RA. Okay, position vector RA. It can be denoted with respect to this x-axis and this y-axis. Okay, with respect to this x-axis and this y-axis. Okay, now if I take this translating axis at point B, say along this direction you have x-axis and y-axis, right? Say this capital X, capital Y, it has translated to this point, right? So this is a new frame. This is your reference frame. Okay, so now this B to A, position of A with respect to B, right? How can you denote that? RAB. RAB, you can denote that, right?
Yes, sir.
So basically, we can say that RA is equal to RB plus RAB. Okay, we can say this from translating axis. Or if we take the differentiation with respect to time, then what do we get? R dot A will be equal to R dot B plus R dot AB. Position of this with respect to this. So what he will get is velocity of A will be equal to velocity of B plus velocity of A relative to B. Okay, so velocity of this point A will be equal to velocity of B plus relative velocity of A with respect to B. Similarly, if you take double derivative with respect to time, you had acceleration of A is equal to acceleration of B plus acceleration of A relative to B. Just a moment. Okay, so we can just write that. Right? So basically what here we consider is two particles A and B, which may have separate curvilinear motions. So A and B, they can have separate curvilinear motions. Now this is your translating plane, right? Separate curvilinear motion in a given plane or parallel planes. Now here we have arbitrarily attached the origin. Okay, this is your reference and this is an axis that I have chosen to B, right? So basically we have seen that RA equal to RB plus position of A relative to position of B. Now if I take this X and Y axis at point A, right? This is RB with this respect to this origin, right? This is RB, this is RA, and position of B relative to A is RBA, right? So here, what are you going to get? RB is equal to RA plus RBA, B slash A. B slash A means relative position of B with respect to A. Okay. Similarly, you have velocity of B equal to velocity of A plus velocity of B relative to A, and acceleration as acceleration of B equal to acceleration of A plus acceleration of B relative to A. Now these are two separate particles. Okay, these are two separate particles, and here you did not have a rigid body. Now on a rigid body, what happens is you have a rigid body like this. Now here you have one particle, here you have one particle. So this body, when it is translating, right? When this body is translating, say in this direction, right? Then what is happening? This is my rigid body. This is point A. Say this is point B. Velocity, say position of point A is say RA and position of point B is RB, right? So velocity will be R dot A and R dot B. Now if it is just simply translating, right, then what do we have? Will we have any relative velocity component here?
No, sir.
So that will be equal in case of a rigid body. So velocity of A will be equal to velocity of B in case of a rigid body, and this is not similar to that what you have observed in case of particles. Okay, now why this concept is required? Because the rigid body motion that we are going to represent as combination of translation as well as rotation about a point. Suppose you have a rigid body like this, right? Now the final position of the rigid body is like this. Okay, so here can I denote it like this? Say this was your initial position, right? Say my body has translated up to this position, and now finally it is rotating in this direction, say about a point A like this, and it is attaining this position, right? So translation plus rotation about a fixed point, that we are going to consider. Translation and rotation about a fixed point, that we are going to consider. Okay, see here, this is your x-axis, this is your y-axis, this is your rigid body, this is your point A with origin O, position vector of A is RA, with origin B, the position vector of B is RB. Again, position vector of B will be equal to RA plus R. This is RBA, this is RB slash A, which means position of B relative to A. Now, since it is translating like this, okay, since it is translating, so velocity of B will be equal to velocity of A. There will be no relative velocity component. Okay, here this is your translating coordinate system. So RA, RB, RB by A. My x dash and y dash axis is this one. With respect to this x dash y dash axis, it is RB slash A, or relative position of B with respect to A. Okay. And similarly, acceleration will be equal to acceleration of A, right? So it is true for all points on a rigid body, and it follows particle kinematics. It follows particle kinematics. Now, point A and point B, they are fixed in the body. Hence, VB equal to VA. But for a particle system, what did we have? For a particle system, VB equal to VA plus VB slash A plus VB slash A, right? So we can have that. So VB is equal to VA plus VB slash A. B with respect to A. Now have a look at this. Have a look at this. See here. So this is a body that is rolling without slipping. Slipping means it is not sliding here on this plane. It is not slipping. So this body, it is just rotating like this. It is just rotating like this. This is your A1, okay, and this is your point B1. It has rotated and it has reached this position here, right? So can I just write it? So this is A1, this is B1. Now this center, it has moved to this point on a straight line. So this is my reference, this center, it has reached this point. And point B, okay, point B, what has happened to that? It has rotated like this, say to position this one. Okay, now this point which I was considering as B1, it has rotated, right? So there is one combination of sliding motion and rotation of point B about fixed point A, right? So this is my A2. So A1 has reached A2 via translation, okay? B1 is represented by B1 dash in that case, and then it is rotated. So B1 dash to B2 by say some angle theta. Okay, say by some angle theta. Okay. Pawan sir. Yes, sir. सर आप अपना बोर्ड यूज कर रहे हैं तो उसका सी टाइप केबल दीजिएगा मुझे, सिर्फ केबल चाहिए, नहीं तो बहुत परेशान हो रहा हूं मैं कुछ लिख नहीं पा रहा हूँ। सिर्फ केबल चाहिए। मैं ये वाला केबल से अपना मोबाइल कनेक्ट कर लिया, मुझे थोड़ी पता था कि आज कनेक्शन नहीं रहेगा। Just a second. Just a second. Right, so I could manage something now. Anyways, sorry students, I think it is not working. Just a minute. Let me just check out. Hello, students, you are there still?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, got disconnected. Really sorry about that. Right. So, so we were here at this position. We were here at this position. So, for this general plane motion that you have this circle, right? It is we can say that it is a combination of translation and rotation about A. Now, when this roller, it is rolling and it is reaching this position, there has been some movement in the center, right? There has been some movement in the center. Okay, so here, say I have a circle like this. Okay, this is my center point O, right? This is my center point, and say this is point A. Okay, this is point A. This is point A. Okay, now this angle say it is 30 degree. Okay, it is 30 degree, and here say this is R0, which is equal to 200 mm, correct? And the radius, this is 300 millimeter. Okay, now this is center point. The velocity of O is 3 meters per second, right? Now it is said that a wheel of radius 300 meter, it rolls to the right. Okay, wheel rolls to the right, okay, and has a velocity v0 of its center O. Okay, v0 is velocity of the center O, 3 meters per second. Now you need to calculate velocity of A for the instant that has been represented. Calculate velocity of A. Now, how can I apply this concept, right? So it has moved by, say, 30 degree. Okay, now this is point A, right? Now, if I take a frame of reference here, x-axis and y-axis. Okay, if I just take a frame of reference at the center point O, x-axis in this direction, y-axis in this direction at the center point O, right? Now, this rotation, I can say that it is a combination of translation as well as rotation, right? So here I can say that velocity of A is equal to velocity of A, velocity of O plus velocity of A with respect to O. Okay. Right. So I'll just come to this one. This is just for your explanation. I will come back to this problem again. Right? How this can be solved. So general plane motion is neither a translation nor a rotation. It can be considered as the sum of translation and rotation. Now suppose I had shown you the circular wheel. Now say you have an arbitrary body like this, right? Now this arbitrary body, it has taken this shape after some instant of time, right? So now I can convert it to translation plus rotation. Translation plus rotation, right? Now translation plus rotation. Okay, so what is happening is this A1, it is translating to first A2, B1 is translating to B1 dash, right? Then I am fixing this point. Try to understand this. Then I am fixing this point A2 and I am giving rotation to this body. Then I am giving rotation to this body and it is achieving the final configuration. It is achieving the final configuration, right? So from here to here, right? So from this configuration to this configuration, what is happening? The body is translating to this position shown by the dotted line, and then it is rotating about this fixed point O. Okay. So during this translation, this velocity of A1 will be velocity of B1. Okay, right? So at this position of also, say this is velocity of A, here also this is velocity of A, and at this position, this was equal to velocity of A. Velocity of A will be velocity of B, right? Now, as this point is rotating to this point, okay, as it is rotating to this point, okay, say it is turning by amount, say d theta, right? And say this radius is r, right? What can I say? So from here to here, the velocity will be of point will be what? R d theta by dt, which is nothing but your r omega. Okay, so here you had velocity of A. Now at this point, velocity of A was equal to velocity of B, right? And finally, by through rotation, it is reaching this point B2. Okay, it is reaching point B2. Okay. So during this phase, my velocity is what? R omega. So now what can I say? VB is equal to VA plus velocity of B with respect to A. Correct? VB at this position will be equal to velocity of A plus velocity of B with respect to A. Right? Now this velocity of B with respect to A,
promised
this
us
is
something
nothing
that
but
he never
your
gave to
R
us.
d
By
theta
looking deep
by
inside the
dt.
crab game code, or
Okay,
actually,
this is nothing but
just
your
looking at
R
the crab
d
game
theta
about
by
page
dt,
thing,
and
you
it
could
can
see
be
that he
expressed
clearly
as
said
omega
that one of the features
cross
is that there's milk.
R.
There's no milk
This
in this
velocity,
game.
it can be expressed as
You may say
omega
that there's the milk
cross
carton
R.
cosmetic,
Okay.
but that's not
Now
a
this
real,
is again a
it's not
vector
real
quantity.
milk.
This
It's
is
just
again
a
a
carton.
vector
And now
quantity.
that there's no
This
more
is again a
updates to the
vector
game, I'm
quantity.
afraid that we
Now
might
omega
never
will be
actually
what?
see it in the game. He lied
Perpendicular.
to us.
Say this,
And there's
if this
only
is
one
my
way to actually get it
in
into
this
the game,
plane,
by
if I have my
subscribing
x
right
and y
now.
axis, okay, perpendicular to the plane will be my axis of omega. Say that is k cap, in direction of k cap. Say it is given that omega is say 10 rad per second. Okay, so in vector notation, I can denote it as 10 k cap. Say if I consider anti-clockwise as positive. Okay, so 10 rad per second. Okay, then it will be in vector notation 10 k cap.
Hey Tech Lead here, and
Rad per
welcome back
second.
to another episode
Now
of
this
the
r
Tech Lead.
vector.
Today we're
This
going to
r
talk
vector
about
will
a
be
very
what? Position of B with respect to A. So here you find the position vector of B with respect to A. You find the coordinates of B, you find the coordinates of A, you subtract it and you find this. So velocity of B you can easily find out if you know the velocity of A in plane motion of a rigid body. Are you getting my point?
Yes, sir.
Is it okay?
Yes.
So based on this, we are going to see some numericals. Okay, how to apply this concept, we are going to see. Okay, see here, similar to this one. See this body that you have. This is point A, this is point B, right? This is VA and this is VB because of some plane motion. Because of some plane motion, velocity of, you have some velocity of point A, this is velocity of point B. There is translation as well as rotation. Now, how can I express it? So translation with A, right? So from I am translating this body initially. So this point will have same velocity. Point A and B will have same velocity because they are points on a rigid body. Okay, this is VA and this is VA. Now it will move to its final position by fixing A and giving it a rotation. Now when I am giving this rotation vectorically, it will be omega into k cap. Anti-clockwise if I take it as positive and say this is my x axis and y axis with respect to point A. Okay, this is my reference axis that I have taken here. I'll just come back here. See here, this was your B and this was your A. This is my unknown. My known point is my fixed reference. Okay, my known point is my fixed reference. So this position vector of A with respect to B, this is denoted by RA/B. So similarly, when I am coming to my this problem, this is omega k cap. Say point A is known, velocity of A is known, right? This is my x dash coordinate, this is my y dash coordinate, right? This is my position vector of B with respect to A, right? And along this direction, when I'm giving rotation, this is my VB/A. Okay. Now again, you must note one thing is that this VB/A, it will always be perpendicular. Okay, it will always be perpendicular to this vector, this position vector. How? Just come here, just come to this point. Here, see, here you had this R and V vector to be perpendicular to each other. Okay, this R vector and V vector, it was perpendicular to each other. Okay, because this is the tangent point. This is the tangent point. To the tangent point, I have drawn this radius. So both of them, they are perpendicular to each other. Okay, so here also, you must note that VB/A, it is perpendicular. This is omega. Through point A, perpendicular to this plane, you have omega. The position vector is RBA. Basically, you are rotating this. There is some rotation of point B, say about this axis. So if I just draw a tangent, so this is your VB/A, B with respect to A. Okay, V with B/A because of this rotation now. So finally, what I can write is VB equal to velocity at point A plus velocity of B with respect to A because of this rotation. Because of this rotation, it is nothing but omega vector cross RB/A vector. Okay, omega cross RB/A vector. So with respect to x and y, you can easily find out the position vector of B, and omega is already, say, it is given to you, and you can easily find this one. Okay, or rather say omega you have to find out. I mean, some points will be given to you and you have to find out the other point. Okay, say RB/A you can find out, VA is known to you, VB is known to you, you have to find out omega, right? Or omega is given to you, RB/A you can find, VA is known to you, velocity of B you can find it out, right? So this is how we proceed. So any plane motion can be replaced by a translation of an arbitrary reference point A and a simultaneous rotation about A. So VB equal to VA plus VB/A. So this is how you draw the vectors. This is your A vector, this is your V vector, VB vector, and here you join it, velocity of B with respect to A, relative velocity of B with respect to A. Right? Now this V/A, it is omega k cross position vector of B with respect to A. And basically this is nothing but r omega. If this is r, if this is omega, the magnitude of VBA is r into omega, and vectorically you can find it out in this manner. Okay, so you have got a little bit idea about this one.
Yes, sir.
Yes, sir.
So tomorrow what we are going to do is we are going to see some numericals based on this. See here, so VB equal to VA plus omega k. So we are going to make use of this one in our coming class 2. Okay, see here, similarly, okay, we are going to discuss all these things in tomorrow's class, and we are also going to take that rotating ball problem, this rotating ball problem, right? How to find out the velocity of A at some instant. If the velocity of my center is known, right? If velocity of my center is known, then velocity of A will be equal to velocity of O plus velocity of A with respect to O, right? Now velocity of O was already given to me 3 meters per second in this direction, right? So if this is my reference axis at the center, it will be 3 I cap meters per second plus VAO will be what? VAO will be what? Again, omega cross R A slash O. Okay. Now, if omega is known to me, okay, then what can I do? I can easily find out the velocity of point A at that instant, right? Now, say, right, okay. So, we are going to take this numerical in the next class, right? So this is just for your example. Numericals we are going to see, and some more problems or some more exercises we are going to see it tomorrow. Okay, so it is almost 10 now. You can go to your next class.